Hey, hello and welcome to today's GFG problem of the day, better string. Let's quickly go through the problem to understand. Given a pair of strings of equal lengths, Geek wants to find the better string. The better string is the string having more number of distinct subsequences. If both the strings have equal count of distinct subsequence, then return string 1. So let's quickly see what is a subsequence, right? So what the problem is asking us, let's say if there is GFG, right, as a string 1 and the string to GGG. Now what the problem is asking us, we have to return the better string, and better string in terms of what? In terms of maximum number of subsequences, right? So what is a subsequence first of all? So a subsequence basically is the order of characters, okay, coming in the order. Is a set of characters coming in order but not necessarily contiguous. So here so here G F is a subsequence. Yes, it is a subsequence. It's in contiguous, but G G is also a subsequence. See, it is in order, but it is not contiguous. It is not next to each other, right? So this is a subsequence. Okay. So a subsequence for a string can be an empty string, one, right? So if it is GFG, right? So then one subsequence can be G, one subsequence can be GF, right? One subsequence can be FG. Okay. And yeah, so these are the number of okay. So yes, then we have uh, GG as well. Okay. Okay. So these are the subsequence G. Okay, yes, and few more, like, right, individual these as well. F, G. Okay, so 0, 1, 2, sorry, 1, 2, 3, 4, 5, 6, 7. And one more can, yes, one more will be GFG, right? So there are 8 subsequences over here, 8 subsequences. So if you observe, if it is a single character, a string with single character, then its subsequence will be the count of distinct subsequences, or the count of subsequences will be 2. Two how? One is empty string and one is A, right? One is empty string and one is A. So for a single character, it will be 2. If you see for AB, it will be like, again, this empty string, then A, then B, okay, right? And then AB, okay? So four subsequences we have, 4 distinct subsequences we have. So if you observe the pattern, right? If the string was with single character, then the count of subsequence was 2, right? Empty string and A. Then we had AB with 2 characters, right? The count of subsequence is 4. And if it was 3 characters, then the count of subsequence was 8, right? 8. So if you observe the pattern, right, whatever is the number of string, right, if it is n characters, then 2 raised to n, 2 raised to power, okay, 2 raised to n is the number of subsequences, okay, for a string. But here the catch is that we want distinct subsequences. So this number will have all the subsequences, distinct and non-distinct as well. Okay, so we want to calculate, for a string we want to calculate the number of distinct subsequences. So let's take an example here. Okay, if the string is ACBC, okay, ACBC. Okay, if the string is ACBC, so for this, right, how many subsequences will we have? First, we'll have an empty string. Okay, one subsequence. Then if we consider A, then we'll have empty string and A, 2 subsequences, right? And then if we consider C, what I'm doing is I'm considering the previous subsequences and then making new subsequences, right? So previous subsequences, and for A, I'd added empty string here and then A, right? For this C, I'd added previous subsequences, empty string A. Then I'm making new subsequences through these previous subsequences. See, adding C to empty space gave me C, right? Adding C to A gave me AC. Similarly, then for B, I added the previous subsequences, empty string, A, C, AC. Then I'm making the new subsequences using this, adding this B. B to empty string made B, right? B to A made AB. B to C, adding B to C made CB. Adding B to AC made ACB. So 8 subsequences. Now see, now here's example where the characters repeated. So for this, what I did first I copied all the previous subsequences over here, right? These eight previous subsequences, I have copied the previous subsequences. Then I am making new subsequences. So adding C to empty string made C, C to A made AC, right? And following C to C, CC, ACC, and all. Okay. But if you observe, we already had this C and AC, right? Here again we got C and AC. So these are not distinct subsequences, right? So these are not distinct subsequences. Okay. So we have to subtract these number of subsequences from the result. So ideally till C, right? How many characters are there? A, C, B, C, right? So according to our formula, 2 raised to 4, right? 4 characters, A, C, B, C will give us 16 ideal subsequences. And there were non-distinct subsequences, two number of non-distinct subsequences we had. So we have subtracted 2 from the 16. We got 14 over here, right? We got 14 over here. So the thing is, whenever we find a character which has already appeared, okay, which has already appeared previously, then we have to see what we have subtracted 2, right? So wherever the character was appeared, right, previously, right, wherever the character was appeared before that, whatever was the count of subsequences before before the occurrence of the character, whatever is the count of subsequences, we have to subtract that. Okay, we have to subtract that from the result, from the current result. Okay, why? Because C we had added to two number of previous subsequences, right? Two number of previous subsequences. So we have to minus this basically. Okay, we have to minus this from the result. So yeah, so that is why 16 minus 2. Okay. So yes, I hope you've got. Let's go through the code. Maybe you'll have a better understanding. I've already implemented this. Okay. So first, what we are doing is we are calling this function count of subsequence to have the number of subsequences, count of number subsequences in string one. Okay. So what we are doing is here, first we are having CNT one, right? CNT is one for empty string. If the string is empty, just return one, right? Then what we are doing here is we will be now iterating through the characters of the string. Okay, through the characters of the string. And what we are doing, if we find this character and we are initializing this array, ASCII array with -1. Okay, so whenever we find the character for the first time, right, if it is -1, the location is -1, then we are adding the previous count to this, the current one, right? If it is a, if it is a, then we are storing the previous count. Why? Just to have this one, right? So we can, whenever we get this, we encounter such situation, we have to we have to consider the previous count, right, to subtract the previous count. Okay, so we will be storing the previous counts, right, for the first character. If it is a, if it is a okay, if it is a, then we are storing the previous count, that is 1. And then we are definitely like it is 2 to the power, right? So we are going to multiply 2 to the count. Okay, so the count has become 2 now. Earlier it was 1, the count has become 2 now. Okay, so so in this way we'll move. But whenever we encounter that, okay, some characters has already appeared, right, has already appeared, like in our case C. So what we are doing, we are fetching we are fetching the count of the character which has already appeared for C, right? For C, what it will give us? 2 it will give us, right? 2 it will give us. And then we are storing the new count now. That is the previous count only, okay, which we have calculated till now. Okay. And then we are going to increment considering the latest C, okay, considering the latest character by 2. And then we are going to subtract this. We are going to subtract this step, 16 minus 2, 14, right? As a count, we are going to subtract the previous count. Okay, and then we are just returning. And then if you see, and we are calculating for string 2 as well, and we are checking here, whoever is greater, whoever's count is greater, we are returning the string accordingly. So let's see. Yes. Okay, the solution is accepted. Also, we are adhering to the space and time complexities, right? That is O of max string one length or string, that is n only, right? We are iterating. Okay, we are iterating here. Okay, and auxiliary space as well. We are taking extra auxiliary space. Okay, so thanks for watching. Kindly like the video and subscribe to my channel. Thank you so much.